Our planet is a world of water. From space, it is a shimmering blue marble, a testament to the vast oceans that cover more than two-thirds of its surface. We have sailed these waters for millennia, charting coastlines and mapping the shallow seas. Yet, beneath the sunlit waves lies a realm that remains more mysterious to us than the surface of the moon. This is the deep ocean, a world of crushing pressure, profound darkness, and unimaginable cold. It is a place that holds secrets we are only just beginning to unravel. For so long, this abyss has been a blank space on our maps, a source of myth and legend. But now, it is revealing itself to be a frontier of breathtaking discovery. The deep sea calls to our innate sense of curiosity. It is the ultimate wilderness, a place untouched by the direct hand of humanity for most of our history. Down in these silent depths, life has followed a different path. It has adapted to conditions that we would find utterly hostile. The rules of the sunlit world do not apply here. Instead, life is forged in chemical reactions and thrives in complete and utter blackness. Exploring this world is not just about finding new species, it is about understanding the very limits of life itself. Every journey into the abyss is a voyage into the unknown, promising glimpses of creatures and ecosystems that challenge our understanding of biology. Imagine descending miles below the surface, leaving the familiar world of light and warmth far behind. The pressure builds with every meter, becoming so immense it could crush a submarine not built to withstand it. The temperature plummets to near freezing. Here, there are no seasons, no day or night, only a constant, unchanging environment. It is in this seemingly inhospitable world that we are finding some of the most vibrant and extraordinary communities on Earth. These discoveries remind us that our planet is full of surprises, and that its capacity to support life is far greater and more varied than we ever imagined. The deep is a library of natural history, and we have only just begun to read its first pages. The allure of this hidden kingdom is powerful. It represents a fundamental challenge to our spirit of exploration. Just as we look to the stars and wonder what lies beyond, we must also look down into the heart of our own planet. The creatures that dwell here are not monsters from ancient tales, but are real, living beings that have evolved in isolation for millions of years. They are part of our planet's rich tapestry of life, and understanding them is crucial to understanding the health and complexity of our world as a whole. The journey into the deep is a journey into our planet's own mysterious heart, a quest to complete the map of our home. The ocean is not one single environment, it is a series of worlds, layered one on top of the other. The surface waters, known as the sunlit zone, are familiar to us. Here, sunlight penetrates, allowing photosynthesis to occur. This is the realm of phytoplankton, coral reefs, and the vast schools of fish we know so well. It is a world driven by the energy of the sun. But as you descend, the light fades. First the reds and oranges disappear, then the yellows and greens, until only a faint ghostly blue remains. Below about 1,000 meters you enter a new world entirely, the midnight zone. Here, sunlight never reaches. It is a realm of eternal night. This absence of light fundamentally changes the rules of life. Without photosynthesis, there are no plants to form the base of the food chain. Instead, life in the deep relies on a slow marine snow, a constant, gentle rain of organic debris from the world above. Dead plankton, fish scales, and other particles drift down, providing a meager source of food for the creatures below. Life here must be incredibly efficient, able to survive on scarce resources. Many animals have evolved enormous mouths to catch whatever morsel comes their way, while others have developed a slow metabolism to conserve precious energy in the cold, dark waters. Pressure is another defining feature of this alien world. For every 10 meters you descend, the pressure increases by 1 atmosphere. In the deepest trenches, more than 10,000 meters down, the pressure is over 1,000 times that at the surface. It is equivalent to having the weight of 50 jumbo jets pressing down on you. Organisms living here have evolved incredible adaptations to survive. Their bodies are often gelatinous, composed mostly of water, which is nearly incompressible. They lack the air-filled spaces, like swim bladders, that would be crushed under such immense force. These adaptations make them seem fragile and strange to us, but they are perfectly suited to their high-pressure home. The deep ocean is therefore not just a deeper version of the shallows. It is a completely separate biosphere with its own unique chemistry, physics, and biology. The temperature is stable, hovering just a few degrees above freezing. The darkness is absolute, broken only by the living light of bioluminescence, which many creatures use to attract prey, find mates, or defend against predators. This world is a stark contrast to the dynamic, sun-drenched surface. It is a slow, silent, and immensely powerful realm that operates on a timescale far longer than our own. A timeless kingdom waiting to be explored. To explore such a hostile and remote world, we need extraordinary tools. At the forefront of this modern age of discovery is the Schmidt Ocean Institute and its remarkable research vessel, Falkor 2. This is not just a ship, it is a state-of-the-art floating laboratory, a mobile base for scientists to launch their expeditions into the unknown. It is designed with one purpose in mind, to push the boundaries of ocean science and share the wonders of the deep with the entire world. The ship provides a platform for researchers from around the globe to come together and use its advanced technologies to ask new questions about our planet. Named after the lucky dragon from the never-ending story, Falkor 2 is a vessel of hope and discovery. It is equipped with advanced sonar systems that can map the seafloor in incredible detail, revealing underwater mountains, canyons, and plains that were previously hidden. These maps are the essential first step for any deep-sea expedition, allowing scientists to identify promising areas for closer investigation. The ship itself is a hub of activity, with laboratories filled with microscopes, genetic sequencers, and instruments for analyzing water and rock samples. It allows for real-time science to happen at sea, turning raw data into knowledge almost instantly. At the heart of the ship's exploratory power is its remotely operated vehicle, or ROV, named Sebastian. This underwater robot is the scientists' eyes, hands, and ears in the deep. Tethered to Falkor 2 by a long fiber optic cable, Sebastian can dive to depths of 4,500 meters. It is equipped with high-definition cameras that transmit breathtaking live footage back to the control room on the ship. Scientists can watch on large screens, as if they were flying through the abyss themselves. This technology allows for careful, precise exploration, enabling researchers to observe animals in their natural habitat without disturbing them. What makes the work of the Schmidt Ocean Institute and Falkor 2 so special is its commitment to open science. The expeditions are streamed live online, allowing anyone with an internet connection to join the adventure. School children, fellow scientists, and the curious public can watch in real time as new discoveries are made. They can hear the excitement in the scientists' voices as a never-before-seen creature drifts past the camera. This approach transforms ocean exploration from a remote scientific pursuit into a shared global experience, inspiring a new generation of explorers and fostering a deeper connection to our planet's hidden wonders. For a long time, we believed that all life on Earth ultimately depended on the sun. Then, in 1977, came a discovery that turned our understanding of biology on its head. Scientists exploring the Galapagos Rift found something astonishing: hydrothermal vents. These are like underwater hot springs, fissures in the seafloor where superheated, mineral-rich water jets out from beneath the Earth's crust. This water, heated by magma deep within the planet, can reach temperatures of over 400 degrees Celsius. It is a dramatic and seemingly hellish environment. Yet surrounding these vents, scientists found thriving ecosystems, teeming with life. These vents form along mid-ocean ridges, where tectonic plates are slowly pulling apart. Seawater seeps down into cracks in the ocean floor, where it is heated by the planet's internal furnace. As the water heats up, it dissolves minerals from the surrounding rock. This hot, acidic fluid then rises and erupts back into the cold, deep ocean. As the hot fluid mixes with the cold seawater, the dissolved minerals precipitate out, forming towering, chimney-like structures known as black smokers. These chimneys can grow to be tens of meters tall, spewing a dark plume of mineral particles that looks like thick smoke. The discovery of life around these vents was revolutionary because it was not based on sunlight. Instead of photosynthesis, the entire ecosystem is built on a process called chemosynthesis. At the very bottom of this food chain are microbes, a type of bacteria that can harness chemical energy from the hydrogen sulfide and other chemicals gushing from the vents. They use this energy to create organic matter, just as plants use sunlight. These microbes form thick mats on the rocks or live symbiotically inside other animals. They are the primary producers, the foundation upon which these entire deep-sea oases are built. These vent ecosystems are true islands of life in the vast, food-poor desert of the deep sea. They are hotspots of biodiversity, home to creatures found nowhere else on Earth. Giant tube worms with bright red plumes, ghostly white yeti crabs that farm bacteria on their hairy claws, and dense fields of mussels and clams all crowd around these life-giving springs. The existence of hydrothermal vents showed us that life could flourish in the complete absence of sunlight, using only the chemical energy from the Earth itself. This opened up a whole new realm of possibilities for where life might exist, not just on our planet, but perhaps elsewhere in the solar system. The era of deep-sea discovery is far from over. In fact, it is accelerating. Recent expeditions aboard Falkor 2 have unveiled wonders that continue to expand our knowledge of life. In just the last few years, scientists have charted vast new hydrothermal vent fields, each with its own unique community of animals. Off the coast of Mexico, an expedition in 2023 discovered a series of stunning vents with whimsical names like the Mops and Twin Peaks. These vents were adorned with shimmering blue and metallic minerals, creating an otherworldly landscape unlike any seen before. Around them, new species of worms, snails, and crustaceans were found, each perfectly adapted to its specific chemical environment. One of the most remarkable recent discoveries has been the existence of entire ecosystems living beneath the seafloor. During an expedition to a well-known vent field, scientists decided to look under the volcanic crust. They used the ROV Sebastian to place boxes over cracks in the seafloor to see what might crawl out. To their astonishment, they found a hidden world. Mature tube worms and other vent animals were living in a network of subterranean caves and tunnels, bathed in the warm, nutrient-rich fluids that flow beneath the ocean floor. This finding suggests that the habitat for vent life may be far more extensive than we ever realized, a hidden biosphere just below the surface. The sheer diversity of life being discovered is staggering. Each expedition seems to return with a treasure trove of new species. We are finding animals that defy our expectations, like the yeti crabs that cultivate gardens of bacteria on their claws to feed on. There are translucent sea cucumbers, bizarre gummy squirrel octopods, and countless species of tiny crustaceans and worms, each playing a role in these complex ecosystems. These are not just scientific curiosities, they are living examples of evolution's ingenuity. They show us the incredible variety of forms that life can take when faced with extreme challenges, providing new insights into genetics, adaptation, and survival. These discoveries are made possible by meticulous and sometimes serendipitous exploration. Scientists aboard Falkor 2 often operate with a plan, but they remain open to the unexpected. On one expedition, while transiting between research sites, the ship's mapping system detected an unusual feature on the seafloor. They decided to investigate and ended up discovering a massive, previously unknown seamount, an underwater mountain, that was teeming with life. This highlights a key aspect of science discovery often happens when we are looking for something else. The deep ocean is so poorly known that almost every journey into its depths brings the potential for a world-changing revelation. Our ability to witness these deep-sea marvels is a direct result of incredible technological advancements. For centuries, the deep was a black box, accessible only through blind dredging or nets that brought up mangled specimens. Today, we can explore it with a delicacy and precision that was once the stuff of science fiction. The remotely operated vehicle, or ROV, is central to this revolution. Robots like Sebastian are our proxies in the abyss, robust enough to withstand the crushing pressure while being nimble enough to perform complex tasks. They are connected to the surface by a hair-thin fiber optic cable that can transmit vast amounts of data, including multiple high-definition video streams. Pilots in the ship's control room operate the ROV using joysticks, watching its progress on a bank of screens. They can maneuver it with centimeter-scale accuracy, allowing them to fly through fragile coral gardens or hover just inches from a hydrothermal vent. The ROV is equipped with powerful manipulator arms that act as the scientists' hands. These arms can be fitted with different tools to collect samples of rock, water, or even delicate organisms. They can deploy sensors, drill into the seafloor, and carefully place instruments. This allows for a level of interaction with the deep-sea environment that is both intimate and non-destructive, preserving these fragile habitats. Beyond the ROV, a suite of other technologies is crucial for discovery. Advanced multi-beam sonar systems on the hull of Falkor 2 create detailed three-dimensional maps of the seafloor as the ship sails. These systems send out fans of sound waves and measure the time it takes for them to bounce back, building a picture of the underwater topography. This allows scientists to spot features like seamounts, ridges, and canyons that are likely to be hotspots for biodiversity. It is this mapping that guides the ROV dives, turning a blind search into a targeted investigation and dramatically increasing the efficiency of exploration. New sensors are also changing what we can learn. In addition to cameras, ROVs can carry instruments that measure temperature, salinity, and chemical composition of the water in real time. This data can be overlaid on the video feed, giving scientists a complete picture of the environment they are observing. Genetic sequencing technology, now portable enough to be used on the ship, allows for the rapid identification of new species from tiny tissue samples. This combination of robotics, mapping, and advanced analytics has opened a window into the deep ocean, allowing us to see, touch, and understand this remote world in unprecedented detail. Exploring the deep ocean is far more than an act of satisfying our curiosity. It is fundamental to understanding our planet as a complex, interconnected system. The deep sea plays a critical role in regulating our global climate. It absorbs vast amounts of heat and carbon dioxide from the atmosphere, acting as a buffer against climate change. The currents that circulate through its depths help to distribute heat around the globe, influencing weather patterns everywhere. By studying the processes at work in the deep, we can create better models of our climate and predict how it might change in the future. The health of the deep ocean is inextricably linked to the health of our entire planet. Furthermore, the unique life forms we are discovering have immense potential for science and medicine. Organisms that thrive in extreme environments, like hydrothermal vents, have evolved unique biochemical properties. The enzymes produced by chemosynthetic bacteria, for example, can function under intense heat and pressure. These have potential applications in industrial processes, from manufacturing biofuels to developing new detergents. Other deep-sea organisms may hold the key to new antibiotics or anti-cancer drugs. The genetic library of the deep sea is a vast, untapped resource that could provide solutions to some of humanity's most pressing challenges. The study of these extreme ecosystems also pushes us to think about life beyond Earth. Hydrothermal vents show us that life can exist without sunlight, powered by geothermal energy. This has profound implications for our search for extraterrestrial life. Moons in our own solar system, such as Jupiter's moon Europa or Saturn's moon Enceladus, are thought to have liquid water oceans beneath their icy shells. It is possible that hydrothermal vents exist on the floors of these alien oceans, potentially supporting life in a manner similar to what we see on Earth. The deep sea is our best analog for these distant worlds, a natural laboratory for astrobiology. Finally, we must explore the deep to protect it. As technology makes it easier to access the deep sea, it is becoming a target for resource extraction, such as deep-sea mining. Without a proper understanding of these ecosystems, we risk destroying them before we even know what is there. Exploration by vessels like Falkor 2 provides the baseline data needed to make informed decisions about conservation. It reveals unique and vulnerable habitats that need protection. Our journey into the deep is not just a quest for knowledge, but a race against time to understand and safeguard the last true wilderness on our planet, ensuring its wonders are preserved for generations to come.